Welcome to EDU World Space.
Hi, in the given problem here, there is a pole which is kept against a smooth wall and at the rough ground. Here, this is the pole.
Here's a clean and professionally formatted presentation of the calculation shown
whose
in the
height is given as,
application of the work
if we
energy
consider
theorem,
this
wet.
point to
From the
be
work
A
energy theorem, the
and
force
this
F is
point
given
to be
by
B,
F equals
then
frac text
its
KE,
height,
where
AB,
KE equals kinetic
which may be
energy,
symbolized by
S
L,
equals stopping distance.
is given
I'm
as
given for object A,
26
FA equals
feet.
frac 100,000,
Here, this
0.10.
point
For object
is
B,
the
FB equals
center
frac
of mass of this
225,
pole,
1500 equals
so
0.15
its
text
weight
makes
will
in.
be
And
acting
force ratio frac FA,
vertically
FB
downward here.
equal frac 0.10, 0.15
The normal
equal
reaction
frac 2 null
of
result.
ground
A box
at
frac
point A,
FA, FB. Would you like a
let it
PDF
be
version of this explanation?
NA, and the normal reaction of the wall at point B of the pole is NB. As the wall is smooth, so there will be no force of friction acting against this end B of the pole when it will be sliding down or up. But when the end A of the pole will be sliding towards left, a force of friction will act here, F, small f, which is given as mu times of NA. Now, first of all, we will equate all the vertical and horizontal components of the forces for this pole to be in equilibrium or we can say at rest. There should be no net vertical or horizontal force. Hence, we can say this NA is equal to weight of this pole, because there are only two vertical components of the forces, only two vertical forces. One is this NA and another is this W. So both of them should be equal and opposite. Similarly, in order to balance the horizontal motion, this F, the force of friction, should be equal to NB. Now, first of all, force of friction F is given as mu times of NA. So we need not to use this concept. We will use it later on. For the time being, F equals to mu into NA. Now, as the pole is neither rotating about point A, so we will take an equilibrium of rotation also. Now, as the pole is not even rotating about point A, so we will consider equilibrium of rotation also about point A. So we can say clockwise torque is equal to counterclockwise torque. About end A of the pole. So looking again into the figure, suppose this angle is theta, as this is the center of mass, so this is L by 2. Similarly, if we consider this distance to be D, we have to find this distance, the distance of end A of the pole from the wall. If this is D, then this distance here will be d by 2. Here, this is d by 2. The perpendicular distance of line of action of W from this point A is d by 2. Hence, the clockwise torque is W into d by 2. And counterclockwise torque will be provided by this NB. And this will be NB into BD. Now putting all the known values for this NB, this is equal to force of friction into BD. If you look in this right angle triangle ABD, in right angle triangle ABD, BD by AB perpendicular by hypotenuse is sine theta. So BD will be AB sine theta. Hence, here it becomes AB sine theta. Again, in left hand side, this is W into D by 2. In right hand side, it is F. And for F, again we know, mu into NA. So this is mu into NA into AB sine theta, where AB is nothing but L. L sine theta. So now for NA, this NA is nothing but W. Hence, mu into W into L sine theta, W into D by 2. Cancelling this W, D is equal to 2 mu L. And now for sine theta, this is 1 minus cos square theta, because in this right angle triangle, we know the value of cos theta base upon hypotenuse. Here base AD, this is unknown, we have to find it, and hypotenuse AB is known. That's why we have converted it into cos theta. So finally plugging in all known values, D is equal to 2 times of 0.3 multiplied by 26 feet square root of 1 minus base, which is D square, by hypotenuse, which is 26 again. So here it becomes D is equal to 15.6 feet square root of 1 minus D square by 676. Now, making a square of both the side, squaring both the sides, we will get D square is equal to 243.36. 1 minus D square by 676, or D square equals to, expanding this bracket, 243.36 minus 0.36 D squared. Then we will shift this term towards left hand side. So it will become 1.36 D square equals to 243.36. Finally, D square equals to 243.36 divided by 1.36, which will come out to be 178.9. Hence, D is equal to square root of 178.9 feet. Finally, it comes out to be 13.4 feet. So this is the distance of the foot of the pole, which is from the foot of the wall, at which this pole will not slide down. Thank you.